Did you know that carbon is not your average element, but a superstar that forms more compounds than all other elements combined? From the tires on your car to the bubbles in your favorite soft drink, carbon is everywhere. And here is the most incredible fact: every living structure on this planet is carbon based. That's right, we literally owe our very existence to this element, and that's why a whole chapter is dedicated to this remarkable element. In this video, we will get to know some interesting details about carbon, such as what are carbon compounds, the type of bonding in carbon compounds, characteristics of covalent compounds, versatile nature of carbon. So let's begin. What are carbon compounds? Carbon compounds are defined as chemical substances containing carbon. Carbon combines with a lot of elements like hydrogen, oxygen, nitrogen, and sulfur to form countless carbon compounds. And guess what? The number of these carbon compounds exceeds 3 million. These compounds are used in clothes, medicines, books, food, fertilizers, fuels, and a whole lot more. So, carbon is literally everywhere around us. But how does carbon combine with so many different elements? It is because of covalent bonding. Before we dive into the explanation of covalent bond, let's understand why elements actually form bonds. Elements bond to form compounds in order to become stable. An element can achieve stability by completing its outermost shell. For example, hydrogen has one electron in its outermost shell, and it needs one more electron in its outermost shell to become stable. Similarly, oxygen has 6 electrons in its last shell, and needs 2 more electrons to become stable, as its outermost shell completes at 8 electrons. So, remember, the elements we are going to study in class 10 need 8 electrons in their outermost shell to become stable, and the only exception is hydrogen, that needs 2 electrons. Now these elements can get these electrons from other elements, and that is called chemical bonding. Atoms of different elements can bond together through either ionic or covalent bonds. Ionic bonds occur when one atom loses one or more electrons to another atom, which then gains those electrons. Ionic bonds occur between metals and non-metals. For example, sodium, Na, and chlorine, Cl, can form an ionic bond to create sodium chloride, NaCl, also known as table salt. Sodium loses one electron to become a positively charged ion, Na positive, while chlorine gains that electron to become a negatively charged ion, Cl negative. The resulting attraction between Na plus and Cl forms the ionic bond in NaCl. On the contrary, covalent bonds occur when two atoms share one or more pairs of electrons. This type of bond typically occurs between nonmetals. For example, a chlorine atom has 7 electrons in its outermost shell, and it needs one more electron to become stable. When two chlorine atoms come together, they share 1 electron each, forming a covalent bond or Cl-Cl bond. Remember, in covalent bond, each shared electron belongs to both the atoms it is being shared with. Now both chlorine atoms have 8 electrons. This sharing of electrons leads to the formation of the Cl2 molecule. After a quick explanation of different kinds of bonding, now let's discuss bonding in carbon. Carbon has 6 electrons and its electronic configuration is 2,4. Which means that it will need 4 more electrons to become stable. Now, will it become stable by forming ionic bond or covalent bond? As mentioned before, carbon forms covalent bonds. But why it does not form ionic bonds? The reason is that it cannot gain electrons because the size of carbon is small, and it cannot hold 4 more electrons. It cannot lose electrons because a lot of energy is required to lose 4 electrons. So the only option carbon has is to share electrons to form covalent bonds. We understand the concept of covalent bonding is new to you, so let's solidify our understanding with examples of covalent bonds in compounds such as hydrogen, hydrochloric acid, oxygen, nitrogen, and methane. Before continuing with the video, here is an important note. Questions from NCERT are usually asked in the exam from this chapter, so make sure to practice all the NCERT questions. Solutions to NCERT questions are provided on the EduRev app, which are written by experts. Now, let's begin with simplest of all molecules, hydrogen, H2. Hydrogen molecule is made up of two hydrogen atoms that share their electrons with each other. Each hydrogen atom has only one electron, which means it has an incomplete outermost shell. But when two hydrogen atoms come together, they can share their electrons to complete their outermost shell. This sharing of electrons forms the covalent bond, also known as the HH bond. Now, let's talk about hydrochloric acid, HCl. Hydrochloric acid is made up of hydrogen and chlorine atoms. Hydrogen has one electron in its outermost shell, while chlorine has 7. To become stable, the hydrogen atom shares its electron with the chlorine atom, forming a covalent bond. This sharing of electrons leads to the formation of the HCl molecule. Moving on to the oxygen molecule, O2. An oxygen atom has 6 electrons in its outermost shell and needs 2 more electrons. When two oxygen atoms come together, they share 2 electrons each, forming a double covalent bond. This sharing of electrons leads to the formation of the O2 molecule, which is responsible for the air we breathe. Now, nitrogen has an atomic number of 7 with 5 electrons in its valence shell and needs 3 more electrons. 2 nitrogen atoms share 3 electrons each to form a stable N2 molecule. The nitrogen molecule has a triple covalent bond between the 2 nitrogen atoms. Let's discuss covalent bonding in a carbon compound, such as methane. The methane molecule is made up of carbon and 4 hydrogen atoms. Carbon will form covalent bonds with 4 hydrogen atoms, where each hydrogen atom shares an electron and the carbon shares 1 electron each with the hydrogen atoms. The total number of electrons in carbon now is 8. And the total number of electrons in each hydrogen is 2, which completes its outer shell. From all the examples discussed, it is clear that covalent bonds are of 3 types: single, double, and triple. A single covalent bond is formed by the sharing of one pair of electrons between 2 atoms. For example, in hydrogen molecule, a double covalent bond is formed by the sharing of 2 pairs of electrons between the 2 combining atoms. Example of double bond is oxygen molecule. A triple bond is formed by the sharing of 3 pairs of electrons between the 2 combining atoms. For example, nitrogen molecule. Moving on to one of the most important topic of this chapter, characteristics of covalent compounds. Covalent compounds have low melting and boiling points, which means they can easily turn from a solid to a liquid or gas when heated. This is because intermolecular forces in covalent compounds are weaker than those in ionic compounds. They also tend to dissolve easily in organic solvents like alcohol, but they are not very soluble in water. This is because water molecules have a strong attraction to each other, making it difficult for other molecules to dissolve. Finally, covalent compounds do not conduct electricity. This is because electricity is carried by charged particles, like ions or free electrons, and covalent compounds don't have any charged particles that can carry electricity. Now, in the beginning of the video, we discussed how there are millions of carbon compounds known to man. It is clearly evident that something is different with carbon, but what is it that makes it so unique? It is the versatile nature of carbon that helps carbon to form a large number of compounds. Mainly, the versatile nature of carbon is due to 2 properties of carbon: tetravalency and catenation. The first property is tetravalency. Tetra means 4, which means that the valency of carbon is 4. The 4 valency of carbon means that it can combine and form bonds with 4 other atoms of carbon, or atoms of other elements such as fluorine, chlorine, hydrogen, etc. We have seen the example of methane where the carbon combines with 4 hydrogen. These bonds made by carbon are strong, making these compounds very stable. But what does it mean by carbon compounds being stable? It means that carbon compounds do not break, and carbon is able to hold other elements close to it. This is because the size of the carbon is small, and it can hold onto the shared pair of electrons, hence making the bond strong and carbon compounds stable. The next property is catenation. The carbon can combine with other carbons to form long chains which can be either straight, branched, or in the form of rings. This property of carbon to form bonds with other atoms of carbon, giving rise to long carbon chains, is called catenation. Similar properties are shown by silicon, but its extent is less as compared to carbon. These are the two properties responsible for a large number of carbon compounds, and that's why carbon compounds is an entire chapter in itself. We hope that you have understood the topic. And now, you should start studying this chapter with the Edurev app as you get video lectures, notes, variety of questions like MCQ tests, short and long answer questions, sample papers, and so much more, for all the chapters of each subject. It's like having the entire school in your pocket.